Welcome to Calc Chats 18. Today we're going to be talking about related rates, what they are, and how to find them. Normally when we talk about rate, we're looking at the derivative. So the instantaneous rate of change, that's talking about the derivative. So this is all just another way that we are connecting derivatives to stuff that we've already learned in geometry and maybe algebra. And so related rates, they use the derivatives to kind of connect our static variables to their rates of change. So this is kind of a confusing statement. We're going to look at what this actually does, but basically we're just relating variables to their rates of change. And so first off, we have a squared plus b squared equals c squared. So this first step is just reminder, implicit differentiation. So let's just differentiate this. So a squared plus b squared equals c squared. I need to use implicit differentiation. So the derivative of a squared is just 2a times dA plus 2b times dB and 2c with times the derivative of c. And so normally when I would implicitly differentiate something, I would move all my dx's on one side, all my dy's on the other, and then divide. But here I kind of have three variables, and so I can't really differentiate this with respect to anything. But below, this second question is asking us to differentiate with respect to time. So this is how we're going to be dealing with a lot of our related rates. So if I wanted to differentiate everything with respect to time, this would look like 2a times the derivative of a with respect to time plus 2b times the derivative of b with respect to time. And again, 2c, the derivative of c with respect to time. So I'm just taking each thing, I'm implicitly differentiating it. Instead of with respect to nothing, it's with respect to time. So this first example tells me that water runs into a conical tank at a rate of 9 cubic feet per minute. Now the tank is standing point down and has a height of 10 feet and a base radius of 5 feet. And it's asking me to find out how fast the water level is rising when the water is 6 feet deep. So when we're dealing with related rates, what we want to do is we want to drift. So first we want to draw a picture. Then we need to recognize known variables, identify unknown variables, and then find a formula to relate the unknowns and the knowns, and then TBT to algebra. A lot of this is just algebra, but the calculus starts up here. So drift is calculus, and then put it all together to get algebra plus calculus, I guess. So our first step is to draw a picture. So I have a cone. It's facing down, and it gives me the height is 10, and my radius is 5, so r equals 5. And I have some water flowing into it. And so for those of you who are familiar with geometry, we'll remember that the volume of a cone is equal to 1/3 times pi r squared h. And so these are my knowns. So I know that my height is 10 feet, my radius is 5 feet. I know that my water is coming in at 9 cubic feet per minute. What I'm trying to figure out is how fast the water level is rising. So how fast the water level is rising, we're looking at the change in height. So here is where I'm looking at my dH dt, right? And it gives me that I'm looking at that when the height is 6 feet. So looking at my volume formula, I don't have a dH dt. And so what I first need to do is I need to figure out what exactly I want to differentiate this in respect to. So if I notice I have an r squared and an h, but here it doesn't give me much about my radius, right? So it only gives me stuff about the height. And so I can relate the radius to the height though. If I noticed when my height was 10 feet, my radius was 5 feet. And for those of you who throw back to geometry, we kind of can deal with similar triangles. So I have this triangle with h is 10, r is 5, and so I'm going to compare that scale factor 5 to 10 equals my radius over my height. The reason I'm setting up this proportion is I'm trying to get r in terms of h. So I find out, sorry, this should be divided by 10, not 5. Divided by 10, divided by 10. So my height is always, or my radius is always half of my height. So what I can do now is I can plug into my original volume formula, 1/3 pi, and then for r, I'm going to plug in h divided by 2 squared times h. So this looks like 1/3 pi times h squared over 4 times h. And if we want to simplify this just a little bit more, volume equals 1/12 pi h cubed. So now I'm dealing with one formula with h. And so if I differentiate this, I can put that in terms of dh dt. So differentiating volume in terms of time, this just looks like dv dt equals 1/12 pi. And then the derivative of h cubed is 3 times h squared dh dt. So all I'm going to do is I'm just going to plug in what I know. So it told me up here, water is running into the tank at a rate of 9 cubic feet per minute. Cubic feet, that's my volume. So I'm going to plug in 9 for dv dt equals 1/12 pi times 3, and then I'm looking at where that height is 6 times dh dt. And from here, all this really is just some basic algebra. So moving along, I end up with 9 equals 9 pi times dh dt. And then when I divide both sides by 9 pi, I end up with dh dt equals 9 feet per second. And it's important that we have these units because h is measured in feet and t is measured in seconds, so 9 feet per second. So the second example gives me a police cruiser is approaching a right-angled intersection from the north. So they're going down and they're chasing a speeding car that has turned the corner and now moving east. And so it gives me the cruiser is 0.6 miles north of the intersection and the other car is 0.8 miles to the east. And that they're determining that the distance between them is increasing at 20 miles an hour. And so if the car is moving at 60 miles an hour, what is the instant or what is the speed of the car that they're chasing? So I'm going to drift. So I'm first going to draw a picture. So this is my police car, and he's moving down towards the intersection. So here's my right-angled intersection. This is my other car. There's a window. He's moving east, and this distance between them is increasing at a rate of 20 miles per hour. And this is 0.6 miles. This is 0.8 miles. And so first off, this just looks like straight Pythagorean theorem. So x squared plus y squared equals z squared. I'm just going to put it in terms of x, y, and z. So here's x, y, and z. And so if I just differentiate this in respect to time, I get 2x dx dt plus 2y dy dt equals 2z dz dt. So I know the cop's change is 60 miles an hour. I'm looking for the other car's change, and I'm given that z's change is 20 miles an hour right here. But what I'm not given is I'm not given z, and so what we want to do first is find that distance z. So find how far apart the two are. So all we're going to do is we're just going to use Pythagorean theorem for that. So 0.6 squared plus 0.8 squared And this ends up actually being 1 squared. So z equals 1 mile. And so I have x equals 0.6, y equals 0.8, z equals 1. So these are all my knowns. The x dt is 60, dz dt is 20. And the COP is coming down. And so this rate of change is actually negative because this distance is decreasing. So this is actually a negative rate of change versus both of these rates of change are increasing because if we notice they're both going to the right, they're both becoming bigger. So dx dt is negative, but dz dt is still going to be positive. So these are my knowns. My unknowns are dy dt. This is what I'm looking for. I don't know dy dt. But now I already had the formula because I had to use it to find z anyway. So I have the formula I want to use. I already differentiated it. And so I'm going to put 2 times 0.6 times dx dt was negative 60 plus 2 times 0.8 dy dt, and I'm running out of room, equals 2 times 1 times, this was 20, dz dt was 20. And so again, I kind of went forward and just did some of the algebra on my own, but we get negative 72 plus 1.6 dy dt equals 40. And so I move that 72 over, I divide both sides by 1.6, and we should get that dy dt is 70 miles per hour. And so these were just 2 examples of how to use related rates. So we're going to be looking at a lot of different examples, but this is just kind of the basis. We need to figure out what formulas we want to use. We need to understand our knowns and unknowns in order to actually use those formulas as well. But basically, we're just using an implicit differentiation to help us find how our variables are related to our rates, and we can check at instantaneous points. So this is kind of just an end of the Calc Chats ramble, but come to class with any questions that you may have, and we're going to be working on this over the next 2 days, so don't feel like you have to get it right now, but just come to class with an open mind, and yeah, please like and subscribe to my channel. Thanks for watching.